We have talked about current, length of arc or arc length. Now you're going to talk about angle of electrode. What's angle of electrode? When you are welding remember in theory we talked about the forwarding positions you weld in. So with those forwarding positions, they also require a different electrode angle or angle of electrode. So this metal you can see it's flat on the ground, meaning this is it's in the flat position or what we would call 1G position. So with this, I think partly these electrode angles, you could say they are common sense. So you can't be, let's say this is our joint here. You want to weld here. So I don't think you would put your electrode pointing like this. And I don't think you would let your electrode point this side, yet you want to weld here. Meaning electrode angle is basically your position, or you direct your electrode in the direction where you want to weld. So if I want to weld here automatically, you can see the electrode is going to be upright. If I'm going to weld a T-joint, I want to weld here to join this metal and the bottom plate. So I don't think you have your electrode now upright like this. Meaning if you put upright, it's just going to be welding only on the bottom plate. Meaning you not be joining this. Hope you are seeing where we are going with the electrode angles or angle of electrode. Meaning if you are going to weld here, automatically I think you have to, if you put so much like this, you'll be welding only on the top plate. So if you have your angle like this, automatically you see you're welding on the top plate. If you have it like this, you're welding on the bottom plate. So what should it be? This and this, these two joints, they make 90-degree angle here. Meaning for you to join these two plates, meaning your angle should be 45. Meaning this is how you should be welding. You are joining this and this at the same time. So that's what we call work angle. So the electrode angle, most times we are always adjusting two angles. So that angle which enables us to weld this and this is what we call work angle. But the way SMAW works, you are depositing metal. So you can't have this. Yes, you can have it like this, but there's what we call drag angle. You incline it on this side. As I'm welding, I'm dragging this electrode in the direction where I'm going. Are you seeing what I'm doing? That is drag angle. What's the use of this drag angle? When you have the electrode like this, meaning it's depositing directly there, and most times what will happen, the metal you're depositing there will be building up and it's up choking your arc. This is sometimes the analogy that you need the electrode to be breathing. Once you establish the arc, it's burning, sometimes it's depositing metal. You need to have some space. You deposit metal on the behind, so that as you are moving forward, you have space for more deposition at the same time, giving space for this electrode to be breathing. So that's why you need the drag angle, but of course not too much drag angle. If it's too much like this, now you are sending metal just in space. So we need that drag angle. I know practically if you try it or you have ever tried it, you realize that could be the reason why sometimes you find your electrode is sticking so much. You light as you start welding, you see it sticks, meaning your electrode is not having space to breathe. So maintain your drag angle. So work angle 45, drag angle, this is 90. It's 45, but this is from this side coming this side, that's work angle. So from this side, we are going to be welding in this direction. So from here, coming here, it's making 90 degrees. So incline it by around 10 to 15 degrees. So drag angle is around 75 or 80 degrees. Then you can weld very well. So now for this, when we are starting, realize that we don't start with doing joints. So we shall start with getting some scrap metals, and we just try to weld bits, passes. on flat metals like this. Actually, with these metals, we do what we call building up a pad. You'll see it in the video, whereby we put beads, passes in sequence like this, and we end up filling the plate with another layer of metal. So with that now, meaning our work angle, that's from on this side, you come here down, that's 90 degrees. Our drag angle, the same around 80 degrees here. So with that, you strike your arc, scratch, bring it up, maintain your arc length, then you weld. So this movement, the way you see how I'm dragging the electrode, that's what we call now speed of travel. So this speed of travel, basically as these metals are melting, this feed our core metal is melting and is being deposited on the workpiece. So this is as basically as sometimes when you see trucks on the roads depositing either marram, sand. So there's a certain layer you want to deposit, a certain amount. If you move slow, you're going to deposit a lot. If you move so fast, you deposit less. So meaning that travel speed, you need to have it consistent to deposit a reasonable, consistent size of a weld bead. Yes, so far we have talked about current, length of arc, what we call arc length, angle of electrode, speed of travel. Now the last parameter is manipulation. This one, when we are going through our semester, it comes a little bit later in time. And please also note, this, we don't digest this knowledge in 1 week or in 1 day. This is a progressive knowledge. You keep digesting as you keep practicing. With time, at the end of, in weeks, you start having it part of you. So with manipulation, this comes so much in handy when you are going to join metals. Let's say now we have these pieces, the students are going to use them to make his V-groove joint. And the other thing I'm always talking about, V-groove joint, beveling, was like this side. Then student had to keep grinding up to when he has this end at an angle. So why do that? Why have a V-groove joint? Most times I'm talking about V-groove joint. So when you look at this metal, this is 10mm plate. And this is also 10mm plate. I want you to imagine this situation. You want to join these metals like this. And you just weld here. You run your bead, it's nice on top here. If you do that, most times actually if you have your welding machine, you can do it. You weld here, then after get your hammer, you try to break it. You realize that these metals, they will break off very fast. Why? Your weld bead or your joint is just on the surface here. You get it, will just be on the surface here. Meaning your joint, you have not welded it and made it stronger. Whereas when we bevel, hope you can see that difference. Now when I start welding, even if let's say I join them like this, but you can see, so what I've done is I'm able to start welding from the bottom, or what we call technically the root, up to when I reach the surface. Meaning I'm going to be putting weld passes from the root coming on top. So with that, you find I've joined these metals from the root up to the surface. So basically I've made these two metals one metal again. So even if now you get the hammer and try to break them, it will be close to impossible. We would have made these two metals one metal. So that's why you see us talking about beveling, creating a V-groove. There are other weld joint designs, J, single bevel, double V-groove, but most times here for study purposes and at beginner levels, this is enough. But I know when you go in different working environments, you find they have different joint designs. So manipulation. On top of having a strong joint, we don't join them like this. We have a space in between. So this is what we call a V-groove joint with a backing bar. So with this, you can see there's this space. So for you, in order to weld, to join these two metals, you need to apply the manipulation. Meaning, if you run the bead straight like this in the joint, you're just going to be welding only on the backing bar or the bottom plate. But what if you welded coming from this side, going on this side, coming this side, going this side, coming this side, going this side? Meaning you're going to be able to join this, and also join the bottom plate. So basically that's manipulation. It's like even tailors use the same technique to join. If there is a hole in your cloth, meaning to join it, you pass your threads this side to join the other side as you are sewing. So that's what we're also doing. And so this, what I'm doing side to side, I'm doing what we call zigzag. The other side, this side. The other side, this side. This side, this side. But there are other manipulation techniques. There's semicircles, and you have to understand that you apply a technique depending on the situation you are in. In this situation, zigzag is good because you are joining this. So that's manipulation and that's its application. So we have covered all the welding parameters. We talked about current, and that one I'm going to set it. Right now we are going to see how they work in actual practice. Now let's switch on the machine. You see me setting the current. I choose the proper electrode. Then when I start welding, you see me maintaining the electrode angle, travel speed. I will have some manipulation and all the parameters, the 5 parameters we have stated them. So let's go to the other side. We pick some scrap and I show you how we do it. When I was doing scam, we have a scrap pile here. So this scrap pile is for beginning stages. You can't get a beginner and you give him a good metal because basically it's wasting in the start. You can do some words here, but all these you can still have been practicing on them. With the electrodes, we are going to select 2.5. So this is 2.5. So we said we set our current around 90. Between 80 and 90. Set that around 87.